We're going to hear about sustaining coral reefs, another form of life from this planet. I'm just stalling while everybody sits down in case you haven't figured that out yet. If I had a banjo, I'd be playing that. Okay, let's get to our next briefing.
Hello, my name is Caitlin Harris, and today I will be going through the Coral Reef Sustainability through Innovation Act of 2017. First, I'd like to thank Professor Cook and the rest of my team for all their hard work this semester. So our story begins in Papahanaumokuakea in Hawaii, which is a marine protected area, one of the largest in the U.S., and it's home to many coral reefs. Now, I wanted to zoom in on one of the coral reefs within this monument called the Marl Reef. It happens to be one of the largest coral reefs within this national monument. Now, the Marl Reef, pictured here, and many other coral reefs provide many benefits to humans and marine organisms alike, such as biodiversity, coastal protection, tourism, and food. But even though they provide all these benefits, they are facing multiple threats. This map shows a distribution of corals through the world and their threat level. The more threatened they are, the redder the color that you see. A few staggering statistics to go along with this is that 50% of corals have been lost in the past 30 years, and 90% could die in the next 30 years if nothing is done. So what are the problems causing these threat levels? The three main problems are climate change, sedimentation and contamination, and poor fishery management. So climate change is a global threat that requires international action, and it is very difficult to address. One of the reasons it's difficult to address is because of the controversies surrounding human-induced climate change. But 97% of scientists and all the countries here seen in pink all acknowledge and agree that climate change is occurring. So because of this, we will go on to how climate change affects corals. It's a three-pronged issue. It leads to ocean warming, sea level rise, and ocean acidification. This all can lead to coral stress. And one of the main outcomes of coral stress is coral bleaching. So this occurs when a healthy coral, as seen on the far left, loses its algae and it becomes expelled, which has a mutualistic symbiotic relationship with the coral, thus causing the coral to become bleached, as seen in the middle image, and the coral loses its color. And if that algae does not come back to the coral can become dead, as seen in the last image on the far right. We also have to consider localized threats such as sedimentation and contamination. As seen in this photo, this is sediment that has settled on top of coral, and it prevents algae from being able to photosynthesize and get the sunlight it needs to provide corals nutrients. We also have to consider contamination such as sunscreen pollutants and micro and macro plastic pollution. We also have to discuss poor fishery management, such as blast fishing, as seen in this photo, cyanide fishing, and bottom trawlers, which all lead to further coral degradation. Now, the bill that we are going to talk about today tries to provide and mitigate solutions to solve these problems. The Coral Reef Sustainability through Innovation Act of 2017 has two purposes: to incentivize innovation and to award prizes. Now, it seeks to do this through 5 priority programs, which we boiled down into 2 main priorities: reversing coral degradation and alleviating financial hardship. Now we will talk about the solutions that this bill could possibly fund. All the solutions seen here today will go to help reversing coral degradation and alleviating financial hardship. We will first begin with solutions regarding reversing coral degradation, such as assisted reproduction, which can happen sexually or asexual, and through reducing sediments and contaminants. Now, before we get into how we can help through assisted reproduction, it's important to know a little bit of how coral reproduction works. On the left, we have asexual reproduction, where a coral can become fragmented and grow into a new identical genetically coral, or you can have sexual reproduction where male and female gametes will release to form a new zygote and thus a new juvenile genetically different coral. So scientists can help assist corals through asexual reproduction by fragmenting corals, putting them into nurseries, watching them grow, and then when they feel comfortable enough, they will outplant these corals back into coral reefs. We can also help through assisted sexual reproduction, where scientists and labs are finding ways to breed corals to create more resiliency in corals to both temperature changes and pH changes. Now, we also have to consider, how do we reduce sediments and contaminants? With plastic contaminants, we can find or make policies that reduce plastic waste. And for sediments, we can reduce them by reducing our agricultural runoff, which these scientists in Hawaii have done by taking this agricultural road here and paving over it. Now, there are costs and controversies to reversing coral degradation, such as it can be very costly to reproduce corals. For instance, it can take up to $200 billion to replant all of the coral reefs, the Great Barrier Reef. We also have to consider the interactions between genetically modified corals put back into the ocean with the native corals that are still there. Now we will talk about how to alleviate financial hardships. We can do this in 3 ways: through marine protected areas, sustainable fishery techniques, and responsible tourism. So marine protected areas are areas in which human activity is restricted, which allows coral reefs and the marine organisms that live near them to be able to flourish and grow bigger. And once these marine organisms, such as fish, grow bigger, they can go out into unprotected areas through the spillover effect, allowing fishermen to catch bigger fish. Which leads us into sustainable fishing of hook and line. Through targeted, it causes more targeted species to be caught, and thus you have less bycatch. You can also catch bigger fish through this hook and line technique. We also have to talk about responsible tourism, which can happen through premium pricing and voluntourism. So premium pricing is a method used in which researchers can find ways in which the willingness to pay of a tourist to go see these coral reefs, and then thus provide pricing that will go back into conservation and into these coastal communities. Voluntourism can also be a good thing, as it's a blend of tourism and volunteering, where tourists can learn more about coral reefs and it can increase citizen education. But there are costs and controversies to this as well, as many citizens may feel they are being restricted from their traditional fishery practices. They do catch a reduced number of fishes through hook and line, and many citizens may feel an increased dependency on tourists to have economic viability in their communities. Now, how do we measure the success of the solutions we just talked about? We can measure the success of reversal of coral degradation through growth rates of corals, settlement rates, and survival rates. And there are a few key resilient indicators we can also look at, such as coral diversity, which we can measure through number of species and the distribution of the coral. Resistant coral species, such as how many of these species are surviving, and the sedimentation through concentration rates. But there are challenges to coral monitoring. As you can see, the 2 green pieces of this pie chart amount to 80% of studies are only done for 2 years or less. This shows us that we need longer-term monitoring of corals. We can also measure the success through alleviating financial hardship, through monitoring and evaluating resource use, increased social participation rates, and building strong partnerships with these coastal communities. Other financial indicators include unemployment rate, coral-dependent economic growth rate, dependence on federal aid in these coastal communities, poverty rate, and economic stimulus of the prize programs talked about. So our long-term goals is to create thriving, healthy reefs and to create strong local economies within these coastal communities. Thank you, and it's the International Year of the Coral Reef, so if you had fun learning about corals this semester, please visit this website.
Great job. So you talked about assisted asexual and sexual reproduction. Do you think that assisting in asexual reproduction potentially can be cause for like decreasing genetic diversity within the coral? Like if there's more assisted asexual reproduction versus sexual reproduction?
It's definitely a possibility because as you saw on the one slide where we learned about reproduction, through fragmentation you are just creating basically the genetically identical coral, which is why we are also doing assisted sexual reproduction to generate more genetic diversity within the corals.
That was really great. Loved hearing about the corals. I'm wondering about the specifics of the bill, whether it addresses any criteria for the prize money to be awarded. Does a project have to meet any certain criteria of improvement in order to get that award money, or is there some other way that it would be dispersed?
So through the priority programs that we talked about, there are 5 priority programs. To be able to have the prize, you have to meet one of those priorities, but we only talked about the main 2, but there are 5. So if they meet any of those, they are eligible for the prize.
Hi. Hi, great presentation. So you talked about MPAs, and I was wondering if your bill had any provisions for like technology or innovation for decreasing illegal fishing in MPAs, because it's a big issue.
I believe that would be under one of the priorities that deal with coastal communities and how they could further foster help with them. Thank you.